Hello, everybody. I'm glad to see that we've got some fellow .NET developers here and that Java and Node.js hasn't taken over the world yet. So I'm here to talk to everybody about some of the support for LINQ that is available for Couchbase to allow you to more easily query your data out of your .NET applications without needing to learn so much nickel. So I'm Burnett. I'm a software development team lead at CenterEdge Software and a Couchbase community expert. And so we're going to start off with going over a little bit of information about CenterEdge, what we do there, and then move into all the fun stuff you need to know to use Couchbase from .NET with LINQ. So at CenterEdge, we're celebrating our 12-year anniversary this year. We were founded in 2004. We're a team of 50 people in Roxborough, North Carolina, which is a little north of the Research Triangle Park region. And a sister company of ours is Palace Point, which is a 100,000 square foot family entertainment center. Our offices are actually upstairs at their office. Our software package was originally developed for them, but we've now spread and have over 600 customers around the world, including family entertainment centers, water parks, trampoline parks, amusement parks, basically anything in the amusement industry. And our focus is full facility management software, which means their point of sale, their ticketing, group and party bookings, and most importantly to the Couchbase side, the online sales and party reservations. Which is the area of our software where we're utilizing Couchbase, is any of our cloud-based infrastructure that's designed to help support the on-premises client-server applications. So we've been .NET since our inception in 2004. Our customers do use an on-premises SQL application to manage their facilities. But we started using Couchbase back in version 1.8 in 2012 to manage their online stores for caching and also persisting shopping carts. And we did that because we needed the extra stability and scalability that was provided to us by Couchbase that was lacking in a pure SQL environment. In the last couple of years, we've started developing brand new cloud-based products to replace our legacy products that we were using. And for these new products, we've moved to a pure Couchbase system. So we're actually using no SQL servers whatsoever. All of our data in the cloud is being persisted and served directly out of Couchbase for the new products. And this is just a general data flow diagram that shows you how all this data is flowing in our architecture. We're running a cluster of data nodes. We are reading and writing key value directly out of the data nodes as much as possible because that's your most performant way to get data in and out of Couchbase is reading through key value. But then also for more complicated needs, that's where we use the index and query nodes to deliver data to our applications through our web servers, which then synchronize that data with the on-premises applications, as well as allow the users to directly access the cloud applications. So the first thing I want to kind of go over is a little bit of the basics of data modeling in .NET and how to map those models to JSON. If any of you guys have used Couchbase, a lot of this stuff is going to be pretty familiar to you. To start off with, this is an example of a basic POCO. So you just take a basic POCO, and you can see on the right here where it maps into your JSON object. One thing to note here is that Couchbase by default uses camel casing in its JSON serializer. That is changeable. You don't have to go with that default. But you'll notice that the capital letters at the beginning of these property names are automatically converted to lowercase. And that you can use decorators, such as on the IATA and IACO properties there to specify a completely different capitalization scheme or even completely different names for your attributes going into this document. If you want to nest documents, you can do so easily. You just create another POCO and include it inside your main document. As you see, the JSON gets serialized cleanly in the way we would expect. Though one thing to note here is that you'll see that there is no type attribute on the nested document inside it. Type is used generally as kind of a standard to represent if you're coming from SQL, your type would generally be used as your table. So if you had a table of customers in SQL, then in Couchbase you would have a bunch of documents in your bucket which have a type of customer. So you only need that on the root document in your document, not on any of the sub-documents inside of it. And then, of course, you could do the same thing with arrays in JSON, so you just simply include a list or any other kind of list-based construct from .NET, and it will convert that to an array in the JSON document. However, there are a few things that are LINQ specific that we want to add to that, as well as some, I call them good practices. They're not necessarily best practices. I'm not going to say it's the only way to do it. But one thing is, up at the top, you'll see this document type filter, which is being applied to the document. Now, this is important for LINQ. It's not a requirement, but this is telling LINQ that if I'm querying to try to get an airline, to go ahead and filter that to only include documents with a type of airline. So that's helping to give us that concept of type is equal to what we would consider a table from SQL, is having that document type filter attribute. You can define your own attributes by inheriting from the document filter attribute, that's the base, so that you can filter on other things other than type if you wanted to. And you can also apply these programmatically. If, for example, you're using someone else's POCOs that you don't have the ability to apply decorators to, there is the ability to apply them programmatically as well. The other thing is, you'll see I changed the type attribute to read only. This is just to give us some consistency. If you have a get set property there, then it's very easy for a developer to accidentally forget to fill the property or fill it with the wrong thing. By making it read only and pulling from a constant, we guarantee that whenever we serialize this document, it will always have the correct type attribute on it. The next thing is dealing with joins. When you're dealing with joins in Couchbase, the rules are a little different than when we're used to dealing with SQL. You have to, on one side of the join or the other, have the document key, the primary key. You can't join on any attribute like you can join on any column in SQL. So you'll see here that the document on the left, we have the airline underscore 137 key of the document on the right, which is going to allow us to join to that. However, it's important to note that you don't have to have the actual raw key. If we just had an attribute on the left that said 137, we could use that to build the string by adding airline underscore to it as part of our query. But it's usually a little simpler just to store the whole key. It just makes things a little cleaner and a little easier to deal with than trying to build the key dynamically. Now, in Couchbase Server prior to 4.5, you had to have the key on the document on the left for the document on the right. As of Couchbase Server 4.5, you now have the option to have the key on the right for the document on the left. So now we're just going to show you some basic LINQ queries. And this is where it gets fun, because you just write this LINQ query here, where I'm querying an airline document sorted by name, select P, so I'm getting the whole airline, and you'll see that it runs this nickel query. So it really is just like writing queries against Entity Framework or any of the other systems that are out there for using LINQ against SQL data stores. And it's going to run this query, and it's going to give you a list of airlines back. You'll note that the extent1.type equals airline was automatically added into this query because of the document type filter attribute that I showed you earlier, which was indicating to filter it by documents of type airline. You can also run more advanced queries. So this is one where we're looking for airlines that start with A in their call sign, and we're doing a projection to select only a subset of the properties from the airline. And you'll see that that just simply generates a more advanced nickel query. And we've got a pretty extensive cross-section of the LINQ functions that you would expect to have. Anything from date mathematics to string comparisons, likes, contains functions. So generally speaking, if you can think of a way to write a query in LINQ, it should hopefully map to something in nickel pretty effectively. And if not, I'd love to hear about it so we can try to add some more stuff in there. And then our next trick here is doing a join, because as I mentioned earlier, when doing joins, you have to be able to have that key on one side or the other. So there's a specific syntax you want to use when doing a join to indicate that, which is right here where this arrow is, which is using nickelfunctions.key. By calling nickelfunctions.key on airline, we're indicating to the query parser that, okay, I'm using the key here. And so you have to use nickelfunctions.key on one side or the other of your equals statement. But on the other side, where I'm just using root.airlineID, that is where I could build a compound key if I needed to. So I can use string concatenation to build up whatever I need to do out of the properties of the root document to get to that airline document if I didn't have the key stored in this raw form. So that kind of covers most of the functionality that we're kind of used to seeing in SQL. But because of the fact that you can nest documents inside other documents and lists inside other documents in Couchbase, it kind of adds an additional concept that SQL isn't really used to, which is unnesting. So you'll see this document here on the left, we have a list of schedules. And what we can actually do is write, and this is the nickel form of it, if we write this query, unnest root.schedule as schedule, the way I like to think of an unnest operation is just like doing an inner join, except that you're doing it against an array inside your document rather than joining against another document or another table in SQL. And what it will do is it will then flatten that result set, just like a join flattens the result set between two tables. So this is the output from that query. You'll see that the information from the root is repeated on each row, and then it varies the schedule information just like it would if you're doing a join. So to do this in LINQ, you simply include an additional from clause in LINQ. If you're using the functional syntax, the equivalent is doing select many. And what this will do is generate the query with the unnest in it, and then you can filter by stuff from either the root or the schedule. You can sort by information from the root or the schedule, do your select projections. Everything just falls through cleanly. So that covers what I would consider to be kind of your standard LINQ syntax, the things that are normally in LINQ that we can now do with Couchbase from LINQ. But there's also some additional structures even beyond unnest that are offered by LINQ that are not something that's offered by LINQ, but that is offered by Couchbase. So we've kind of given some additional extensions to what LINQ can do. The first is the idea of is missing. In a JSON document, unlike in SQL, you can actually be missing an attribute altogether, which is different than that attribute being null. So if the attribute's there with the word null behind it in your JSON document, that's treated as null like we're used to treating it in SQL. But if the attribute's missing completely, that's something different. So we have nickelfunctions.isMissing, which is specifically going to test for is that missing or not. This can be particularly valuable when you're dealing with your schema having changed over time, and you want to know if this particular document was written before you were writing this particular attribute onto your documents. And there's also another is not missing, which is the inverse, and is valued and is not valued, which is checking for is not valued means it's null or it is missing. The next thing that we have support for is use keys. This actually allows you to select documents from a specific list of document keys. This is the fastest way to run a query because it doesn't have to hit an index at all. It just goes out and it grabs those documents. And it has some advantages if you have a list of a bunch of keys. It's basically allowing you to filter it at the query server before it comes to you and apply sorts and select projections rather than you going out through the key value method and pulling those documents back and then doing it yourself. The other key use of the use keys clause is if you're doing subqueries. So if you're doing another query inside your main query, going off and hitting more documents, you're actually required by Nickel to use keys to do that. So that's where you would use this use keys clause. And then you can actually dynamically build the list of keys going into there from the parent document. But all of that just works the way you would expect from a LINQ query. You just write the stuff and put it in there and it just happens. The next addition is use index. Couchbase is pretty good about selecting indexes to use, but every once in a while you want to improve that performance a little bit. You want to give it an index hint and say, you know what, this index is really the best to use for this query, so let's use this one instead. So calling .useIndex just gives you a way to provide that index hint. But it's generally something you should only do if you know for certain that you really want to use that index. And just let the optimizer pick where it can in other cases. You can only use this use index clause on the first db.query in your query. If you're doing joins with additional db.queries to get other documents, you don't want to put use index clauses on that because indexes aren't being used for the secondary joins because it already has the key directly. And the next thing is asynchronous queries. When you're dealing with, especially on web servers, you're dealing with lots and lots of requests and you're trying to use your threads efficiently, it's always best to write asynchronous action operations. So we added an extra extension to iQueryable called execute async that's going to take your query and run it asynchronously. And then you just await the result and you get your query result back. One of the interesting things though is how do you handle when your query is executing immediately? So for example, aggregates and firsts and singles and other operations in LINQ that typically trigger an immediate execution of your query. And so we actually have an extension of execute async here that takes in a lambda expression where you can continue to apply additional steps to your query, such as adding the average here. And it will actually delay that execution of that average until it actually runs everything asynchronously. And like I said, this will work for any of the functions that you would normally trigger immediate execution, and LINQ can be passed in as part of this lambda. So next we're going to talk about how to efficiently index when you're dealing with LINQ. Indexing is a little different between SQL and Couchbase, so I want to make sure that we go over what some of these differences are and how these differences, you need to account for them. So the first thing I want to talk about is how SQL indexes. This is what we're all used to. I've got two tables here. I've got an airline SQL table and I've got an airport SQL table. And those tables have indexes. And as I mutate those tables, it has to keep those indexes up to date. So anytime I write into airline, it only has to update the indexes of the airline table. And the same for the airport table. This is different than how Couchbase works. In Couchbase, you have a bucket, and the bucket has indexes, and this bucket has lots of different data in it, and we're just using usually the type attribute to tell the difference between these different documents. So this means that anytime I mutate anything into the travel sample bucket, it has to do something to update in some way every single index. Now there might be where clauses on the index that are filtering it so it doesn't apply to some documents, but at the very least it has to read that document out, deserialize it, and check and say, hey, does this index apply to this document or not, even if it doesn't actually then apply that mutation into the index itself. So one of the things you want to watch out for is going crazy with your indexes. Where you can, make one index that actually can cross multiple different document types. So that you have one index that can serve queries of this document type or that document type, and then you only have one index that needs to accept these mutations. And so based on that, I've kind of got three general rules that I apply when I'm making indexes, especially where I'm going to be querying them with LINQ. The first rule is use that where clause. So that you filter that index where the type is equal to airport. Now, when you put a where clause on the index, it will only use that index if that same where clause is present on your query. But with LINQ, because we're using that document type filter attribute, we know that every query is going to have a where type equals clause on it, so that we can then use this in our indexes. And this will help reduce the number of mutations it has to accept. It does still have to test that predicate, but it helps to reduce the size of the index some. The second thing is, like I said before, When we're working with these indexes, and it can be shared across multiple document types, include the type attribute first in the index. So again, we're always querying on the where clause, so it will still be able to hit this index with the type attribute first. But this will make sure that I only have one index that needs to accept mutations on documents related to IDs, and I can still hit this with any query where I'm doing where type is equal to X or where type is equal to Y that also has an ID clause in the where predicate. And the third thing, and this is particularly important, is the fallback. There is nothing worse in a production Couchbase bucket that's of any size than a primary key scan. We all know from SQL that primary key scans are bad. You don't want to ever write a query that hits a primary key scan on a large table. But in SQL, if you got a table that's got 10 rows on it, a primary key scan is not that big of a deal. The issue with Couchbase is that a primary key scan in Couchbase is a primary key scan of the entire bucket, not just one table. So almost invariably in a production data environment, we found that a primary key scan just results in the query timing out and it crushing your cluster while it's running. So you never want to hit that. And the way to prevent that is to put this fallback. If you know, again, that every query has where type is equal to X in the query, then if you put in a fallback index that's just on the type, you know that anytime I run a query, at the worst, it's going to hit this fallback index, which has an equivalent performance profile to a primary table scan in SQL, because at least it's only going to hit all the documents in this one type rather than all the documents in the bucket. So it's just, this is your stopgap in case you messed up, basically. And the next thing to talk about is date times. Date times get a little interesting because JSON doesn't really have native support for storing date times. But at least at CenterEdge, where we're dealing with business applications, date times are something we deal with constantly. From transaction date times to update date times or any number of other date times you can dream up. So we have to have a way to handle that effectively. So the kind of the standard within Couchbase is usually to store the date time is ISO 8601 date strings, which will show up as you see in this query here in the lower right-hand corner of that query. That's what an ISO 8601 string looks like, which also has a time zone specifier in it. And so what LINQ does to help handle this is anytime you're sending in a date time, it always wraps that date time, be it coming out of a property in the document or a constant you're passing in a call to string to millis, which is converting it to Unix milliseconds. So then when I'm doing any comparisons between them, such as it's doing here with a less than or equals, it's always going to handle that time zone specifier. If we just tried to do string-based comparisons, it would work correctly as long as they both had the same time zone. But as soon as they're in two different time zones, you're going to get unpredictable results. So just to make sure that we don't have that problem, LINQ always sends through a conversion to string to millis. The caveat behind this is that your indexes, if you're indexing on that, also need to include string to millis. If you just index on the raw string and then you're doing your comparison with string to millis, the query engine's not going to be able to tell and not going to be able to use that because it indexed on the string. The nice thing is that you have this ability to pass in actual function calls in your index creation, and so it will actually run that function as it creates the index, and then it will recognize that function call in your query automatically and use that index in a nice optimized way for you. And this doesn't just apply to string to millis either. You can actually use any number of other functions in anything that you're using, as long as it's a deterministic function. You can use those in your index to optimize your processes. So the next thing that we'll talk about is change tracking and read your own write. Change tracking is currently in developer preview in the LINQ to Couchbase library. It might change slightly before it actually comes out. Some of it's still being tweaked, but its functionality is actually working at this time. Just beware of slight changes to behaviors in final releases. But change tracking is giving us the functionality that we're used to from like Entity Framework, for example, where I just read the document out, I make a change, and I call save, and it writes the changes back, if any, and if I didn't change it, it does nothing. However, when we were working on developing this, we were debating how to go about it. Entity Framework works doing its change tracking by keeping 2 copies of every row in memory. So when you read out the row, it keeps its base copy and it keeps the copy it gives you. And then when you make changes to it and you call save, it goes through and it makes comparisons. Is this the same or not? And if it's different, it makes the save. With Couchbase, we're typically working with much bigger documents than a SQL row. And the RAM utilization on that can be much more significant. I mean, we could be reading out a 100 kilobyte document into memory and maybe 100 kilobyte documents. So keeping 2 copies of that entire document tree with all of its subdocuments and lists in RAM was going to be a pretty significant memory hit, as well as going through and recursing through that entire tree to try to compare every single property was going to be a bit of a processor hit on the actual save function. So we took a slightly different route, and what we went with is actually document proxies. So whenever you turn on change tracking and you're reading a document out of Couchbase, it's actually going to inherit from that dynamically and create a proxy. And it will override all of the properties that are virtual, and so that when you call a set on it, it can detect that and use that to flag the document as dirty. So this requires a few adjustments to your POCOs to support this. Adjustment number 1 is actually we need to know the key of the document so that when we write it back, we can write it back with that key. To do that, we're actually using the key attribute out of the system.componentmodel.data annotations namespace, the same key attribute the Entity Framework uses, to simply flag a particular property as being the key property. I usually recommend making it a read-only property, but it could certainly be a read-write property as well if you need something more advanced. The second thing to do is all your properties need to be virtual so that they can be overridden and we can, in the proxy, so we can detect changes when you call set on them. And then the third thing that you need to do is with your lists, in addition to list properties being declared virtual just like other properties, instead of being a list of T, it needs to be an I list of T, because we're going to substitute that in with an observable collection rather than just a plain list collection, so that as you add elements to the collection, we can also use that to flag the document as dirty. So once you make those 3 changes to your POCOs, now they're ready to support operating with change tracking. So here is an example of doing a unit of work with change tracking. You start off with a call to begin change tracking. Begin change tracking turns on that proxy operation. It also modifies your nickel queries slightly so that it also queries out some of the metadata even though you're not actively querying it. The next thing is to make sure that you're running, therefore, your query after the call to begin change tracking. If you query before begin change tracking, it's not generating proxies and it won't be able to know that you made modifications. The next step after that is then to simply call submit changes. That's going to take any changes you've made and submit them to the database. There's also an end change tracking that you can call instead if you just want to throw out the modifications and not submit them. But of course, if you're just throwing away this DB object, that's not required. One option that you can do with this is actually, if you're using a dependency injection with a request level scoping, you could begin change tracking at the beginning of your request before this DB object's injected into your controller, and then automatically call submit changes at the end of the request if there were no errors thrown. There's also a couple more helper functions here. One is the remove function. This deletes a document. The second is the save function. This inserts a new document. Both of these functions actually will work outside of a begin change tracking, submit changes context, so you can use them just for modifying or inserting new documents without calling begins change tracking. The difference is if you call them outside of a change tracking context, it will trigger them to perform that mutation immediately rather than waiting for you to call submit changes in order to perform the mutation. The next thing is read your own write. Now, read your own write is only supported in Couchbase Server 4.5 or later, but it is typically pretty useful when you're dealing with making a modification and then the user immediately going back to the screen where they had the list before and you want your modification to show up in that list. When you're dealing with SQL, indexing is immediate as part of your transaction. When you modify a row in SQL, it's not going to come back to you and return until the indexes are updated as well. In Couchbase, for performance reasons, that index update is delayed. And it will just go ahead and return and say, okay, I've got your data, but it might be a little while before the indexes are up to date. So if you're going back and trying to redisplay that list, you want to wait until that index update is complete before you display the list so that you know that those changes are there. And the way we do that is with read your own write. So anytime you make mutations in the data context and you call submit changes, or even if you're outside the change context, you just call save or remove. It's updating a property on the data context called mutation state. This mutation state is basically a collection of specific incrementing numbers that work across V buckets and all sorts of fun, fancy stuff that I don't even entirely understand myself. But if I take that and pass that mutation state into the query, then it's going to guarantee that that query the indexes are up to that point with my previous writes before it's going to move on and execute this query. Now there is another construct that's available before 4.5 called request plus, where you're basically saying, I want the indexes to be up to date to the point where I'm running my query. So when I send the query in, I want you to stop, wait for the indexes to get up to date to this point in time before you return. But that's less performant than using this consistent with your mutation state, because this is only requiring the indexes to be up to date with the point from 10 milliseconds ago where I actually did my write, rather than the indexes being up to date with right now when I ran my query. So that pretty much covers what LINQ can do. So kind of the next thing I wanted to cover is why at CenterEdge, we went with NoSQL and LINQ, and why I think it's advantageous for other people. One, it's more scalable and performant than traditional SQL in the cloud. Our legacy web store system, I think we started in 2008, is currently running 19 SQL servers, I think, each running 30 web stores. Whereas our new cluster is just a much smaller cluster of Couchbase servers that is right now underutilized as we're in the process of transitioning people from the legacy web store system to our new platform. And it scales much more cleanly. I don't have to deal with, well, if this store is only on this SQL server and that store gets crushed, the other 29 on that SQL server are running slowly. That sort of thing. The other thing is that I think that the support for LINQ, you saw that there's differences. Indexing is a little different. There's some additional commands that you don't have that are new to Couchbase and LINQ that are different than SQL. But it really makes training .NET developers who are almost all used to using LINQ as a query method of a database much easier. They don't have to learn all the ins and outs of NoSQL, which is very SQL-like and very easy to learn too. But it streamlines that process for them. Also, I find the document structure in Couchbase with nested documents to actually be easier to work with than tables. I mean, we've gotten used to, after all these years, dealing with the fact that when I've got an order coming in on my web store, I've got a root order table, and then I've got an order line items and an order taxes, and half a dozen to a dozen or more subsidiary tables, sometimes going 2 or 3 tiers deep that I've got to deal with querying and joining through. When I'm dealing with Couchbase, I just write one document for the order with all of that stuff in there, and actually you're joining much, much less. Sometimes needing that key to do that join seems a little cumbersome, but in reality, you join so rarely because it's all in that one document that it makes things easier and also more performant because joins are one of your big performance hits in querying. And then finally, the schemaless nature of JSON increases the flexibility of the system. There's really in a database, there's not really such a thing, in my opinion, as being truly schemaless. You have to have some kind of schema to be able to understand the data that you're pulling back out. The difference is what happens as my schema changes. With SQL, if I've got a table with 10 million customers records in it and I want to add one column to it, my SQL database is going through and removing or changing the data structure throughout the entire table to add that one column. So part of my upgrade process has to be SQL sitting there churning while it goes through 10 million customer records and adds that column. With Couchbase, it does nothing. All I got to do is adjust my processes to know when that particular column is missing, or the attribute rather is missing. What do I do with it? So it makes evolving the system and having the schemas change a lot easier. There are a couple spots where it might get more complicated. If I've got a string attribute and I want to turn it into an array of strings, that's a little trickier. But there's still ways to do that just with your JSON deserializer and doing some customizations there. So all the source code for the LINQ to Couchbase library is available on GitHub. It's under Couchbase Labs. I will say that it's not currently technically supported by Couchbase and their support department. However, we are using it at CenterEdge in our production systems, and we're all very responsive on the forums, and it is actively developed. So, secondly, all the examples that I had up on the board during this demo are available in an actual working MVC application at couchbase.linq.example, so that you can actually pull up and run the application, see how the queries run, see how to do logging, and extract the actual nickel query from the query, and all that stuff's working. And then finally, questions can come through the Net SDK section of the forums, or you can email me or reach me on Twitter as well. So, are there any questions I can answer for anybody? Did I talk too fast for anybody? Okay, well, if anybody does have any questions, feel free to reach out on the forums. And I guess we're done a little early then. I guess I did talk too fast. So thank everybody very much.